Good evening to one and all. Welcome to sisyaclass. Welcome to the EAPCET mathematics series of sisyaclass. Ee roju podduna madhyanam manam we have discussed about the determinants. Daniki mundu we have discussed about the matrices, and in the prequel, and we have also discussed about the calculus functions, trigonometric functions up to so on. And now we are discussing the climax of determinants. Okay, the matrices lo the last topic that we are discussing, that is finding the solution of homogeneous and non-homogeneous system of linear equations. And there are different techniques in which we are also finding, and also we are going to discuss something called rank. So idi mana agenda. So today we will just confine our discussion to these topics. And నేను ఒక 2-3 days నుంచి కమెంట్స్లో కూడా చూస్తున్నాను that you wanted to have this discussion on homogeneous and non-homogeneous system of equations. So yeah, I'll try to completely describe it and with some tips and tricks and ante. So తర్వాత రేపు మన టాపిక్ వచ్చేసి కాంప్లెక్స్ నెంబర్స్. ఓకే, అండ్ we'll be having even in the afternoon as well as in the evening session both complex numbers, followed by let's see the quadratic equations. Okay, so that's all it is. And ఒకవేళ if you are liking these sessions, please you share with your all friends so that it will have a maximum reach, as it is available live and as well as free on YouTube. So maximum share cheyandi so that right at this point of time it takes so much amount of money to go for a coaching, right? Alantidi oka content matku you are getting something free on YouTube. So please do help your friends as well as us, sharing to maximum people, right? And also there is a Sysya app, right? So please go to Play Store and also download the app called sisyaclass. And మీ క్లాస్లో I'll show you the barcode scanner also, where you can directly scan and also download the app, and also if possible share it to your siblings or the younger ones who are really interested and who are below 10th grade. Right from 1st grade till 10th grade, there is enormous and abundance of information, and the content is available which is very reliable, and meeku enta it is explained in very subtler way, right? It is understood in a very easier fashion, right? So that is how the content has been completely prepared. Okay, so without any further discussion, right, let's completely confine our discussion to the topic of determinants. So okay, so my name is Sai Satish. I have done my masters from IIT Palakkad, Kerala. I have trained over 50,000 students from past 5 years. So let's get started to today's topic called the rank of a matrix. Okay, first and foremost, rank, let's not get into the literature part of what is rank. Okay, I'll just try to make you understand first. Rank ante entante, if you can use some row or column operations in such a way that there is an increasing order of number of zeros. For example, okavela gani, if you can bring a pattern of stepwise zeros, right? Okavela, see, I'm just taking 2, 1, 5, 0, 3, some 7, 0, 0, 5. Okay, so ikkada meer chuste how many number of zeros, and the zeros should be like the increasing order right from the first column. Okay, so it should be in the increasing order. Okay, so that is what the rule is. So okavela number of zeros, it should start in this fashion. Okay, if the number of zeros in the first row and first column here in this particular element, it is here 0, the next row element should have 2 zeros, and the next, consequently in the next, it should have 3 zeros. So it should have like this, and it should be strictly increasing, right? There should not be a pattern like where the number of zeros are same at any two given 2 rows. ఇది ఒక విధంగా అర్థం చేసుకోవచ్చు. దిస్ ఇస్ అ వెరీ లేమన్ లాంగ్వేజ్ టు అండర్స్టాండ్, రైట్? కానీ దెర్ ఇస్ అనదర్ వర్షన్ టు మేక్ యూ అండర్స్టాండ్ క్లియర్లీ. మైనర్ ఆఫ్ ఎ మ్యాట్రిక్స్ అంటే, ఒకవేళ కానీ జస్ట్ ఈ ట్రిక్ ఎప్పుడు గుర్తుపెట్టుకోండి, ఒకవేళ డిటర్మినెంట్ కానీ ఎప్పుడైనా 0 ఉంది అని అంటే దాని అర్థం ఇక్కడ ఈక్వాలిటీ సైన్ అంటే ద ర్యాంక్ విల్ బి లెస్ దాన్ వాట్ ఎవర్ ద స్క్వేర్ మ్యాట్రిక్స్, ఇట్ ఈస్ లెస్ దాన్ n. Okay, n అనేది ఏంటి? ఆర్డర్ ఆఫ్ ద మ్యాట్రిక్స్. ఓకే, ఇఫ్ యూ హ్యావ్ ఎ మ్యాట్రిక్స్ ఫర్ ఎగ్జాంపుల్ 3/3, and if the determinant is turning out to be 0, then the rank should definitely be less than 3. Okay, అది మటుకు ఒక రూల్. ఫస్ట్ రూల్ ఏంటంటే, if determinant is equals to 0, then the rank will be less than 3. We don't know how much exactly it is. It might be 1 or it might be 2. Definitely not 0, because if it is a non-zero matrix, 0 అనే ర్యాంక్ ఎప్పుడు వస్తుంది అంటే ఓన్లీ ఇఫ్ ఇట్ ఇస్ a null matrix. Okay, that is a 0 matrix. Otherwise all the non-zero matrix have rank at least 1 or greater than 1, right? So so at least 1. So when determinant is equals to 0, the rank will be less than 1. less than 3, less than n, whatever. So if determinant is not equal to 0, definitely the rank will be equals to the order of the matrix. Okay, సింపుల్గా ఈ ట్రిక్ ఎలా గుర్తుపెట్టుకోవాలి, ఇక్కడ ఈక్వాలిటీ సైన్ వచ్చిందా, డిటర్మినెంట్ ఈక్వల్ టు 0 వచ్చిందా, ర్యాంక్ అనేది లెస్ ఉంటుంది. ఒకవేళ డిటర్మినెంట్ ఈక్వల్ టు 0 వచ్చిందా, ర్యాంక్ విల్ బి ఈక్వల్ టు. సో దీస్ టూ ఆర్ యాక్టింగ్ ఇన్ దట్ సెన్స్. Okay, determinant equal to 0, rank will be less than n. Determinant not equals to 0, rank equals to n. So this is all the things you need to understand. Okay, okavela gani next, okavela suppose it is turning out that determinant is 0, rank is less than n. Okay, so appudu rank can be either 3, 2, n minus 1, n minus 2, right? So okavela if rank of a matrix is equals to r, if a rank of a matrix equals to r, then ardham enti, pratisari if you take any other minor of a matrix which is greater than r, that should definitely be equal to 0. That should definitely be equal to 0. So ee slide paina you have a complete information that is expressed in terms of the literature sense. You can make so adi meeku ardham avutundi, but nenu em cheppalanukuntunna ante ultimate ga okavela rank 2 annadu anukondi, for example if he is saying rank equals to 2 ante ఏదన్నా కానీ let it be how much ever the matrix size is, let it be 4x4, 5x5, whatever the content is, right? You take the sub matrix, or you can take any sub matrix that is a minor in such a way, for example you can take the minor of 3x3 or 4x4, within that minor the determinant will always be equal to 0, right? And there will be at least one minor of 2x2 matrix which will be not equal to 0. అంటే ఒక్కటైనా కానీ మైనర్ నాన్ జీరో ఉంటుంది. Okay, so that is a simple understanding. ఒకటే గుర్తుపెట్టుకోండి, just don't take beyond your logic. ఎప్పుడైనా కానీ determinant equal to 0, rank less than n. Whenever determinant not equal to 0, rank equal to n. This is all the thing we are expecting in this. Okay, ఇది మీకు అర్థమైతే దీని తర్వాత we can directly discuss about the homogeneous system of equation and non-homogeneous system of equations just using precisely this logic. Okay, okay, so ఇది మటుకు గుర్తుపెట్టుకోండి, just take this as a tabular column. Okay, whenever determinant equal to 0, rank is less than n. Whenever determinant not equal to 0, rank equals to n. This is how the opposite things goes. Okay, so that is the first thing. Next, homogeneous system of equation and non-homogeneous system of equation. Ippudu whenever I say homogeneous, so జనరల్గా సిస్టమ్ ఆఫ్ ఈక్వేషన్స్ అని వెంటనే వీఆర్ టాకింగ్ అబౌట్ ద లీనియర్ సిస్టమ్ ఆఫ్ ఈక్వేషన్స్. ఓకే, లీనియర్ సిస్టమ్ ఆఫ్ ఈక్వేషన్స్ అంటే వెన్ వీ ట్రై టు సీ యాక్చువల్లీ బేసిక్గా మన అండర్స్టాండింగ్ ఎక్కడి నుంచి మొదలవుతుంది అంటే వై వీఆర్ స్టడీయింగ్ మ్యాట్రిసెస్ ఇస్ టు మేక్ అవర్ లైఫ్ సో ఈజీ. ఇట్ ఈస్ అ సోఫిస్టికేటెడ్ టూల్ దట్ మేక్స్ అవర్ లైఫ్ ఈజీ ఇన్ ఆర్డర్ టు ఫైండ్ ద సొల్యూషన్ ఆఫ్ n by n ఈక్వేషన్స్, రైట్? ఇన్ఫ్యాక్ట్ ఒక మ్యాట్రిక్స్ ఒక సైజ్ n ఈక్వేషన్స్ ఉండి n అంటే n కన్స్ట్రెయింట్స్ ఉండి n వేరియబుల్స్ ఉంటే ఇట్ ఈస్ రియలీ on paper it is very hard to imagine how does it actually look, actually how does it manifest, but there is a mathematics that is being involved without even further having such sort of a perception and visualization, but still we are able to find the solution of this sort of things. Ide gaadu, matrices can be used in even the subjects like operational research, right? Our subjects lo kuda linear system of equations will be using in order to find exactly the solution of a system of equations. So it's wide range of applications unnai when you actually enter into the market, and not only that, so many things are there. Okay, so let's not divert into that topic. Homogeneous system of equations ante, if I have taken a system of equations in such a way that all the constants are equal to 0. Constant equal to 0 ante I have a11x. Okay, I'll just take a simple equation. Okay, 3x plus 2y equals to 0, 7x plus 5y equals to 0. దీని హోమోజీనియస్ ఎప్పుడు అంటారంటే వెన్ ఎవర్ ద కాన్స్టెంట్స్ ఆర్ ఆల్ 0, దెర్ ఇస్ నో స్పెసిఫిక్ లైక్ 7, 3 అలా ఏంటివి ఏం లేవు, ఓన్లీ ద రైట్ హ్యాండ్ సైడ్ దిస్ ఈస్ ఈక్వల్స్ టు 0, దెన్ వీ కాల్ దిస్ యాజ్ ఎ homogeneous system. Okay, whenever I say non-homogeneous system, ఒకవేళ కానీ 3x plus 2y equals to 5, 7x minus 11y equals to 2, ఇలా రైట్ హ్యాండ్ సైడ్ ఏదన్నా కానీ ఒక్క ఎలిమెంట్ అయినా నాన్ జీరో ఉంటే దెన్ ఐ కెన్ కాల్ దిస్ యాజ్ ఈ non-homogeneous system of equations. Non-homogeneous system of equations. Okay, so this is what the entire thing is. Okay, so this is homogeneous system of equations, the other one is non-homogeneous system of equations. I hope మీకు క్లియర్, మీకు ఎటువంటి డౌట్స్ లేవు ఇట్లా. ఓకే, సో వీటిని యాక్చువల్గా మీరు చూస్తే దీస్ ఆర్ ఆల్ నథింగ్ బట్ ది గ్రాఫికల్ రిప్రజెంటేషన్. మనం ఎలా ఉంటాయి ఇవన్నీ లీనియర్ గ్రాఫ్స్. ఓకే, మీరు ఆల్రెడీ చూసేసి ఉంటారు లీనియర్ ఈక్వేషన్స్ ఇన్ 2 వేరియబుల్స్లో దిస్ లుక్స్ లైక్ ఏ లైన్, దిస్ ఆల్సో లుక్స్ లైక్ ఏ లైన్, రైట్? యా, Anand, hi. It's difficult to grasp your words. Anand, are you preparing for EAPCET? Can you explain it again, sir? Good evening. It's how many days will you complete maths, sir? Okay. Actually, we have started this class since a long time. Okay. It's been almost 10 days, I think. Approximately 10 days. Even we are taking classes on Sunday. No worries. Anni sessions matuku, all the sessions are there in YouTube Live. The playlist link will be there down in the description right after this lecture. And also, you have the list of content even for the chemistry also. దానికి సంబంధించిన ప్లేలిస్ట్ కూడా ఉంటుంది. So you can have an access. Don't worry about that. And one more thing, like this lectures will go on up till 1 month approximately, that we would like to complete the mathematics series, and maybe precisely even the chemistry lectures could be finished much more before, right? So this is all the thing is. So yeah, it is okay. My words are difficult to understand. Okay, so okay, నేను తెలుగులో మాట్లాడటానికి ట్రై చేస్తున్నాను. So sorry for that if I have used any sophisticated words, but anyways, ఇప్పటి నుంచి I'll try to use as much as the మీ లాంగ్వేజ్లోనే మాట్లాడడానికి ట్రై చేస్తాను. ఓకే, అండ్ యా, సో ఓకే, ఎనీవేస్, సో లెట్స్ సీ. ఓకే, ఇప్పుడు నేను ఏంటంటున్నా అంటే దిస్ సిస్టమ్ ఆఫ్ ఈక్వేషన్స్ ఏవైతే ఉన్నాయో, దిస్ యాక్చువల్లీ మేనిఫెస్ట్ యాజ్ ది స్ట్రెయిట్ లైన్స్ ఆన్ ఎ గ్రాఫ్, right? This is also a non-homogeneous. It also represents as a graph. These are the lines that are passing through the origin, right? These are the lines which are not passing through the origin, right? It has some intercepts, right? But when we see a three-dimensional, for example, three-variable linear equation, right? Linear equation in three variable that represents as a plane, right? When you see a four variable linear equation, we call that all the higher the higher variable equations, like 4 variable, 5 variable, 10 variable, 100 variable, all this sort of a linear equations as hyperplanes. These are called hyperplanes. They, even though they belong to the n dimension, but on when you actually see it, like we have no visualization to see it when we actually go to even fourth dimension also. So it looks like a hyperplane. It looks like a plane irrespective of the dimension that we are talking about, right? In 3 dimension it just looks like a sheet, a plane. Okay, so that is what I wanted to say. So when I talk about the system of equation, 2x plus 3y plus 5z equals to 11, 3x minus 2y plus 2y equals to 2, 4x plus 7y minus 3z equals to minus 3. Okay, so e system of equations matuku ela untayante, it will be in the form of a plane. Okay, these will be in the form of a plane. Now when we are trying to find the solution of this set of equations, we are trying to find what is the intersection of all these planes. Ade manaki whole thing. But irrespective of this sort of a typically research oriented discussion, we would like to confine our discussion to solve the problems. Okay, ippudu chudandi, I would like to give you one table. Okay, first for the homogeneous, okay, homogeneous system ki ax equals to 0. So in ax equals to 0, can you explain rank again? Okay, yeah, you can just see the rank. Ikkada already I have explained you the rank. Okay, rank is nothing but if you try to arrange the zeros in such a pattern, it is in the increasing order, right? Using some row operations and column operations, that is nothing but the rank. That is what, like, normally we intuitively think about a rank. But exactly if I have to explain, you can explain using the determinant or the minor. Eppudaina gaani edaina oka matrix ki if the minor of if a specific order is all the minors are equal to 0, then the rank will be below that. Okay, that is all the whole philosophies. Eppudaina gaani determinant equal to 0 ochindante, that's the highest minor for the for the matrix. If it is equal to 0, then the rank will be less than the 3, whatever the determinant is there. So the same thing goes for if you take minor of any sort of a pair in the whole matrix. If it is turning out to be 0 for every sort of a pair, then the rank will be less than the order of the minor that we have taken. Okay, so this is what the condition of a rank of a matrix is. Okay, and if at all you are not understanding, me eppudaina gaani rank, if you are trying to say that if you can if you can come up with a pattern of zeros using a row operation, man just in 5 minutes we'll try to do the how to find the rank of a matrix. That time I'll clearly show you how to exactly find the rank. Okay, and ee okka note point matku తీసుకోండి, ఎప్పుడైనా determinant equal to 0 ఉంటే rank less than n, whenever determinant is not equal to 0, rank equal to n. So don't don't hesitate, మళ్ళీ ఇంకొక 5 minutes లో విల్ బీ సాల్వింగ్ ద ప్రాబ్లమ్స్ ఫర్ ద ర్యాంక్. అప్పుడు మీకు క్లియర్గా ఎక్స్ప్లెయిన్ చేస్తాను ర్యాంక్ ఎలా ఫైండ్ అవుట్ చేయాలో. ఓకే, సో యూజింగ్ ద సూటబుల్ రో అండ్ కాలమ్ ఆపరేషన్. ఓకే, ఇప్పుడు చూడండి, వెన్ ఎవర్ వీ హ్యావ్ ఎ సిస్టమ్ ఆఫ్ ఈక్వేషన్స్ విచ్ ఇస్ homogeneous system of equation, that is Ax equals to 0, then if rank of A, so when I'm saying homogeneous system of equation, that means if we have 2 equations and 2 variables or 3 equations and 3 variables. So our case lo matuku we have a matrix which we can write it as, for example, I have A11x, so I'll just write it as A11x1, A12x2, A13x3. I'm just taking this for your simplicity. So similarly, I have taken, this is one set of equations. So I have A21x1, A22x2, A23x3 equals to 0, A31x1, A32x2, A33x3 equals to 0. So you can write this system of equation in the pattern of, you can take all the coefficients of the variables, that is A11, A12, A13, A21, A22, A23, A31, A32, A33, and you can take this as x, y, z equals to 0, right? 0, 0, 0. So if you try to do the matrix multiplication, malli you will be getting this sort of an equation itself. Okay, సో ఇక్కడ నుంచి వచ్చింది. ఇప్పుడు ఈ మ్యాట్రిక్స్ని నేను ఏతో డినోట్ చేస్తున్నాను. ఈ వేరియబుల్ మ్యాట్రిక్స్ కాలమ్ మ్యాట్రిక్స్ని నేను ఐఎమ్ డినోటింగ్ ఇట్ విత్ ఎక్స్, రైట్? దిస్ మ్యాట్రిక్స్ యాజ్ 0. సో దిస్ ఈస్ ఇన్ ద ఫార్మ్ ఆఫ్ ఏఎక్స్ ఈక్వల్స్ టు 0. ఇదే నేను చెప్పింది. ఓకే, ఇప్పుడు ఈ మ్యాట్రిక్స్ ఏదైతే ఉందో, ఇఫ్ ఈ మ్యాట్రిక్స్ ఒక ర్యాంక్, ఓకే ఓకే, జస్ట్ సీ హియర్ దెర్ ఆర్ 2 కండిషన్స్. ఫస్ట్, దీనికి ఏమంటాడంటే ఎయిదర్ యూ విల్ బీ గెటింగ్ ట్రివియల్ సొల్యూషన్, అంటే this actually these are all the planes or the lines, whatever it is called, for the respective for the respective dimensions we are talking about. ఇవన్నీ ఆరిజిన్ నుంచి పాస్ అవుతాయి. బై డిఫాల్ట్ మీరు ఇక్కడ 0 సబ్స్టిట్యూట్ చేస్తే ప్రతి ఒక్క వేరియబుల్ దగ్గర ఇట్ విల్ సాటిస్ఫై. అందుకనే ట్రివియల్ అంటాడు. ఓకే, ట్రివియల్ సొల్యూషన్ అంటే బై డిఫాల్ట్ ద సొల్యూషన్ ఇస్ న్యాచురలీ 0. ఓకే, దట్ ఈస్ కాల్డ్ ది ట్రివియల్ సొల్యూషన్, రైట్? సో వెన్ ఎవర్ వీ హ్యావ్ ఓకే, 2 things ఎప్పుడు గుర్తుపెట్టుకోండి. వన్, వెన్ ఎవర్ వీఆర్ టాకింగ్ అబౌట్ ది homogeneous and the non-homogeneous system of equations, there are 2 things that we need to keep in mind. First is the determinant and the next one is rank. ఓకే, సో బ్లైండ్గా ఒకటి ఈక్వాలిటీ ఉంటే ఇంకొకటి ఇన్ఈక్వాలిటీ ఉండాలి. ఓకే, యూ ఆర్ గెటింగ్ వాట్ ఐఎమ్ ట్రైంగ్ టు సే. ద ర్యాంక్ ఈస్ సంథింగ్ వీ నీడ్ టు డీల్ విత్ ద n, దట్ ఈస్ ది ఆర్డర్ ఆఫ్ ద మ్యాట్రిక్స్. ఓకే, ఒకవేళ డిటర్మినెంట్ ఈక్వల్ టు 0 ఉందా, దాని అర్థం ఏంటి? ర్యాంక్ ఈజ్ లెస్ దాన్ n. If determinant is not equal to 0, that means rank equal to n. Rank equal to n. Okay, so determinant ఎప్పుడైతే not equal to 0 ఉందో దాని అర్థం rank equal to n. ఈ కేసులో this is called the trivial solution. It is called the trivial solution, అంటే 0 solution. ఓకే, అంటే 0 కాకుండా there is no other possibility. కానీ ఇక్కడ if you see when det of A is equals to 0, rank of A is less than 1, here this is called the unique solution. This is called the unique solution. అంటే ఒక్కటే ఒకసారి it will try to intersect, right? That is the mutually intersecting point, right? So whenever we have det A equals to 0, మీరు ఏవైతే టెక్నికల్ టర్మ్స్ నేను చెప్పానో అవన్నీ మర్చిపోండి. ఇక్కడ మీరు ఏం గుర్తుపెట్టుకోండి అంటే ఈక్వాలిటీ ఉంది, ఇక్కడ ఇన్ఈక్వాలిటీ, ఇక్కడ ఇన్ఈక్వాలిటీ ఉంది, ఇక్కడ ఈక్వాలిటీ, అంతే. This is all the rule is. Okay, whenever we are having determinant equal to 0, rank is less than n. Whenever determinant is not equal to 0, then rank equals to n. This is all the thing is. Okay, so idi gaani meer find out cheste we are done. So whenever we have determinant not equal to 0, then we have 0 solution. 0 solution ante anni solutions is 0 0. That is trivial solution. Whenever determinant is equal to 0, and then we have a unique solution. Okay, so ఇది మటుకు ద సేమ్. నౌ సిమిలర్గా నేను ఎలా అయితే హోమోజీనియస్ పార్ట్కి డిస్కస్ చేశానో, ద సేమ్ థింగ్ వీ కెన్ ఆల్సో డిస్కస్ ఫర్ ద నాన్ హోమోజీనియస్ పార్ట్. ఓకే, సో హోమోజీనియస్ పార్ట్లో ఏఎక్స్ ఈక్వల్స్ టు 0, బట్ వెన్ ఇట్ కమ్స్ టు నాన్ హోమోజీనియస్ పార్ట్, ఐ హ్యావ్ సంథింగ్ లైక్ ఏఎక్స్ ఈక్వల్స్ టు బి. ఓకే, ఐ హ్యావ్ ఏఎక్స్ ఈక్వల్స్ టు బి. ఈ బి అనే మ్యాట్రిక్స్ ఏమంటాడంటే దెర్ విల్ బి సమ్ నెంబర్స్. ఓకే, లైక్ 2 3 5. ఓకే, లైక్ 2 3 5. Okay, so that will be there when you are taking the non-homogeneous system of equations. So these are non-homogeneous. These are the non-homogeneous system of equation. Okay, so this is nothing but Ax equals to B. Ikkada first thing meer gurtu pettukovalsindi is the same logic again it goes. Here the first thing is rank of A, దీన్ని augmented matrix అంటాడు. దీన్ని ఏమంటాడు? ABని augmented matrix అంటాడు. If rank of A is equals to rank of AB is equals to n. ఇక్కడ చూడండి అన్ని ఈక్వాలిటీ సైన్ ఉన్నాయి. ఇప్పుడు నేను డిటర్మినెంట్ గురించి ఏం మాట్లాడచ్చు? డిటర్మినెంట్ షుడ్ నాట్ బి ఈక్వల్ టు 0, రైట్? సో వెన్ ఎవర్ వీ హ్యావ్ ఎనీ సార్ట్ ఆఫ్ అన్ ఇన్ఈక్వాలిటీ దెన్ డిటర్మినెంట్ విల్ బి ఈక్వల్ టు 0. ఇఫ్ ర్యాంక్ ఆఫ్ A is equals to rank of AB, నేను ఈ AB గురించి I'll just let you know in some time. If it is less than n, then determinant will be equal to 0, and if rank of A is not equal to rank of AB, then I can say the determinant is also equal to 0. But in the either of these two cases, I can call the first two cases as the consistent system of equations. Okay, the solution is consistent, and the last one is called the inconsistent. Ante in fact that is a no solution. Okay, the first one here we get, this is the unique solution. Here I get the infinitely many solution, and the last one is no solution. Okay, I hope meeku ardhamai untundi. The first one is the, if I say that rank of A is equals to rank of AB, ఈ AB అనే మ్యాట్రిక్స్ ఎలా ఉంటుందంటే, సో if I have to just explain you here, సో మీరు ఇక్కడ చూడండి AB అనే మ్యాట్రిక్స్ ఎలా ఉంటుందో. సో ఇఫ్ ఐ హ్యావ్ టేకెన్ ఎ సిస్టమ్ ఆఫ్ ఈక్వేషన్స్ లైక్ దిస్, ఓకే, AX is equals to B. So if I have taken A11x1 plus A12x2 plus A13x3 is equals to B1, A21x1 plus A22x2 plus A23x3 is equals to B2, A31x1 plus A32x2 plus A33x3 is equals to B3. Now if you try to take the matrix, that is A11, A12, A13, B11, B12, B13, you know, sorry, this is A21, this is my bad, A21, A22, A23, A31, A32, A33. Okay, ఈ మ్యాట్రిక్స్ మనకు ఆల్రెడీ తెలుసు, it is called the matrix A. Okay, this is called the matrix A. Now whenever I talked about matrix, this augmented matrix A/B, I will also be incorporating all the constants that are there on the right hand side. Remember, this B element should be there on the right hand side, so this will be B1, B2, B3. So this is called the augmented matrix. ఎప్పుడైనా కానీ నేను when I am talking about AB, you will be including even the column elements, that is the constants also. Now I will just do the partition with the dotted lines. Now I can find the rank of A as well as the rank of AB. Okay, so this is nothing but the A and AB. Okay, so I hope me clear untundi. So whenever we are talking about AB matku, we are also taking the union of the constants also that are there on the right hand side, this B elements. Okay, right. So now getting back to the portion. Okay, so this is nothing but the homogeneous and non-homogeneous. Next వచ్చేసి the Cramer's rule. Okay, so Cramer's rule we will be using not very frequently, but ఎక్కడైతే పాసిబిలిటీ ఉందో అక్కడ we'll try to use. Cramer's rule లో ఏమైపోతుందంటే, the first thing is you have a set of equations like this. Okay, ఇక్కడ how you have this, so this is defined by delta. Now when I try to interchange any one of the column with any one of the constants on the right hand side, okay, that will become delta 1, delta 2, delta 3. okay, నేను ఇక్కడ క్లియర్ గా మీకు చెప్తా, ఒక చిన్న ఎగ్జాంపుల్ తీసుకొని. సో హియర్ ఇస్ ది Cramer's rule. ఇక్కడ చూడండి, ఫస్ట్ D అనే టర్మ్ ఏంటి? ఇట్ ఈస్ జస్ట్ ది డిటర్మినెంట్ ఆఫ్ ద కోఎఫిషియంట్స్ ఆఫ్ x and y. ఓకే, D1 అంటే ఏంటంటే ఈ ఫస్ట్ కోఎఫిషియంట్ ఆఫ్ x ని ఈ C1 ఇంకా C2 రీప్లేస్ చేస్తుంది. Okay, and D2 ante you will be keeping the A1 and A2 common for this. Again you will be changing this B1 and B2, the coefficient of y with the C1. The same goes when you are taking the 3 by 3 equations also. Okay, D1, D2, D3, it just progresses in this way. Okay, so the replacement will be any one of the column with the constants. Okay, that is how the Cramer's rule work. Okay, so this is nothing but this system of equations, simultaneous the Cramer's rule to find the solution of system of equations, but we'll be seeing in some time. Okay, yeah, so దీంట్లో ఒకటి ఏంటంటే if the determinant is not equal to 0, then we have a unique solution, right? That we have a unique solution. And if determinant is equals to 0 and if D1 and D2, if these both are equal to 0, then we have infinitely many solution. If D is equals to 0, if any one of D1 and D2 is non-zero, then it is called the inconsistent. That means if you can find if there is at least one D1 and D2, which is it is just like మీరు ఆలోచించి చూస్తే it is just something like this only. A1 by A2 మీకు గుర్తే ఉంటుంది system of linear equation in two variables లో. If A1 by A2 is not equal to B1 by B2, and this is called the unique solution. If A1 by A2 is equals to B1 by B2 is equals to C1 by C2, then it is called infinitely many solution. The same pattern goes if A1 by A2 is equals to B1 by B2, if it is not equal to C1 by C2, then it is a no solution. The same pattern it goes here. Okay, so ikkada chudandi first problem. Okay, we'll try to solve some problems. Okay, let's see how many problems we can solve. The first problem is if the system of equation is represented like this, has only trivial solution antunadu. It has only trivial solution. Trivial solution ante enti? Only zero solution. Now whenever he is saying it is zero solution, ikkada indak nenu cheppinattu logic enti? If det of A is equals to 0, rank of A is equals to 1, n. Okay, sorry, rank of A is not equal to n. If det of A is not equal to 0, rank of A is less than n. Okay, rank of A is less than n. If det of A equals to if det of A is not equals to 0, the rank of A equals to n. Sorry. Okay, so ఎప్పుడైతే determinant not equal to 0 ఉంటుందో, rank will be equal to n. So this is the case where it is having a trivial solution. It is having the trivial solution. So whenever the determinant is not equal to 0, the rank will be equal to n. Rank will be equal to n ante, then we will be having the trivial solution. Whenever I am saying rank equals to n, that means the rank should be equal to 3. Okay, so that is the first case. It is direct problem. It's chala direct problem. Okay, just on the note point. Next, the rank of this matrix is 1, then the possible values for x square. Okay, మీరు ఇందాక అడిగినట్టు I will just try to make you understand what is rank. Now let's try to understand. Rank is nothing but you should make a pattern of increasing order of zeros. That is what I said. So first మీరు ఏం చేయండి అంటే x. Try to make this element and this element 0 using the first row element. So this will become 0. X minus x, again it will become 0, and this will become, so just the column operation is R2 gives R2 minus R1, R3 gives R3 minus R1. Okay, so this will become x square minus x minus x minus x plus 1 minus x. Okay, so ikkada emayipotundi x minus x is 0, so this will become, so we have finally x 0, x into x minus 1, 0, 0, x minus x is again 0, so we have 0 and we have last here 1. Okay, so we have finally this. Now he is saying the rank is 1. Rank eppudu possible avutundi, for what values of x the rank will be 1. Okay, మీరు ఇక్కడ చూస్తే see definitely one complete row should be equal to 0. In fact, two complete rows should be equal to 0. That is how where the rank can sustain to be 1. So only possibility is you cannot make this 1 further to be 0. So only possibility is definitely the value of x should be equal to 0. All the remaining cases will not allow us. For example, మీరు x equals to 1 తీసుకుంటే ఇక్కడ 1 1 1, మళ్ళీ ఇక్కడ 1 minus 1 0, that is okay, but again here you will be having one more non-zero term, but this again turns the rank to be 2. Okay, that rank to be 2. So that is what the only possible case is, not x equals to 1, not x equals to 1, x not equals to 0, definitely not a possibility. The only thing is x equals to 0. So by trial and error method we just found the answer. Okay, నెక్స్ట్ ఇక్కడ చూడండి, లెట్ A be a 4x4 matrix and P be the adjoint of a matrix. If mod P is equals to det A by 2, then A inverse is equals to. Okay, so he's saying P is the adjoint of the matrix where det P is equals to det A by 2. Okay, so చూడండి ఇక్కడ A inverse is equals to adjoint A by det A, adjoint A by det A. Okay, so here he's saying what is det of A inverse ఎలా ఉంటుంది, ఇక్కడ det A అనేది ఒక వాల్యూ. ఓకే, సో వాల్యూ టైమ్స్ ఒక మ్యాట్రిక్స్, ఇది ఎలా ఉంటుంది? సో I discussed in the morning class, det of KA is nothing but k to the power n into det A, k to the power n into det A. Yeah, hi. Yeah, thank you Anand. Okay, now let's see here, det of A inverse I can write it as 1 by so now det of KA is nothing but k to the power n into det A. N is nothing but the order of the matrix. Now what is the order of the matrix here? That is 4. So 1 by det A is just acting like some constant times the matrix. So this will be 1 by det A to the power 4 into adjoint A, into adjoint of A. Okay, into det of adjoint of A. But already we know that P is nothing but the adjoint of A. So in place of adjoint of A, can I write P? So that will become 1 by det A to the power 4 into what is adjoint of A? That will be mod P. Mod P is nothing but again mod A by 2. Mod A by 2. Okay, mod A by 2. But okay, so mod A by 2. So we have det of A inverse is equals to mod A by mod A power 4 by 2. So this will become okay, here one more thing, I just want to clarify one more thing here. Mod P is equals to mod A by 2, right? ఇప్పుడు P అంటే ఏంటన్నాడు వాడు, adjoint of A. Just take this note point, det of adjoint of A, take this as a note point, and even I can in fact derive this one. Det of adjoint A is nothing but det A to the power n minus 1. ఇది ఎలా వచ్చిందంటే, just see here, if A is equals to A inverse is equals to adjoint A by det A, yes or no? Now from here I can write adjoint A is equals to det A times A inverse, right? Now we have a property that det of k times of A is nothing but k power n times of det A. So k is a constant, but here if you see, if I take the determinant on both sides, det of adjoint A, then it will become what? Det of, this is acting like a constant. ఇక్కడ చూడండి, ఇక్కడ కాన్స్టెంట్ ఉంది, det A అనేది కూడా ఒక వాల్యూ, ఇది కూడా ఒక కాన్స్టెంట్. ఇప్పుడు నేను ఈ కాన్స్టెంట్ ని డిటర్మినెంట్ బయట రాస్తే దట్ విల్ బికమ్ det A to the power n into det A inverse, right? Now మీకు ఆల్రెడీ తెలుసు det A power n is nothing but det A whole to the power n, right? Det A power n is nothing but det A whole to, so det A power n into det A power minus 1. So this will become det A power n minus 1. So this is how we can derive the value of adjoint A using some properties of determinants. So I have already derived that this is equals to det of A power n minus 1. But here this P is nothing but det A power n minus 1. Ikkada n enta 4. So this is also equals to det A cube. So he's saying this mod P is nothing but det A cube. Det A cube is equals to det A by 2, right? So from here I can just cancel this. So this will become det A square is equals to 1 by 2. Det A square equals to 1 by 2. So from here I can if I just try to see from here det A power det of adjoint A. So finally I got det A square to be 1 by 2. Okay. So from here if we try to calculate what does he want, det of A inverse. So if we say here det of A inverse is nothing but det of adjoint A by det A, right? So det of adjoint A is nothing but det A to the power n minus 1, that will be det A cube by det A. So this A, let's cancel, we have finally det A square. But det A square value is already how much? That is equals to 1 by 2. So the answer is det A square is 1 by 2. So det A square, so 1 by 2. So this will be, yeah, this will be 1 by 2. Yeah. So see the next question. If a non-singular matrix adjoint of A inverse is, so see here A inverse is equals to adjoint A by det A. So daily classes, yeah, I'll be taking classes every day. Yeah. A inverse is equals to adjoint A by det A. So from here I can write adjoint A is equals to det A into A inverse, det A into A inverse. Now if you see here, adjoint of A inverse ఏమవుతుంది? So can I do some manipulation like this? A inverse whole inverse in place of A inverse, just taking this A inverse as some element B. So B inverse is nothing but adjoint of A inverse by det of A inverse. So the same formula, I am taking A to be another A inverse just in order to get this relation. So from here A inverse whole inverse will become A. So A into det A inverse is equals to adjoint of A inverse. Okay, adjoint of A inverse. Yeah. So now, so A into det A inverse, I can write it as A by, so det A inverse I can write it as A by det A. A by det A is equals to adjoint of A inverse. Adjoint of A inverse. So I finally got this relation as A by det A is nothing but adjoint A inverse. So now if you see here, if you try to establish any relation, ikkada manaku A values gaani daniki supportive ga ledu. So let's try to understand first by option verification. Adjoint of A is nothing but A inverse into det A. So A inverse into det A whole inverse, ఎందుకంటే దానికి whole inverse ఉంది కాబట్టి. Now if I try to take this one, so this will become for the whole thing, this will become 1 by det A into A inverse whole inverse will become just A. So again you are getting A by mod A. So here you got A by mod A, here also you got A by mod A. The answer is option A. Okay, so this is how I got the answer. Okay, clear? ఇక్కడ ట్రిక్ ఏంటంటే A inverse I can write it as adjoint of A inverse by det A inverse. Okay, and from here I can establish this relation. Okay, right. So anyway, ఈ పీడిఎఫ్ నోట్స్ మటుకు కంప్లీట్గా మీకు అవైలబుల్ ఉంటుంది. ఇట్ విల్ బీ అవైలబుల్ ఇన్ ద డిస్క్రిప్షన్. సో యూ కెన్ లుక్ బ్యాక్ అండ్ యూ కెన్ గెట్ టు దిస్, రైట్? సో సీ ద నెక్స్ట్ క్వశ్చన్. ద సమ్ ఆఫ్ ద డిస్టింక్ట్ వాల్యూస్ ఆఫ్ ఎక్స్ ఫర్ విచ్ ద మ్యాట్రిక్స్ హ్యాస్ నో ఇన్వర్స్. ఓకే, ఏం చేయండి, ఐఎమ్ జస్ట్ ట్రైంగ్ టు సే యూ ఫస్ట్ నో ఇన్వర్స్ అన్నాడు. వెన్ కెన్ ఎ మ్యాట్రిక్స్ హ్యావ్ నో ఇన్వర్స్? వెన్ ద డిటర్మినెంట్ ఈస్ ఈక్వల్ టు 0. వాట్ ఎవర్ ద మ్యాట్రిక్స్ వేర్ ద డిటర్మినెంట్ ఈస్ ఈక్వల్స్ టు 0, దానికి ఇన్వర్స్ అనేది పాసిబుల్ కాదు. Okay, so if determinant of A is equals to 0, that means the matrix has no inverse. Whenever the determinant is not equal to 0, then this becomes the prerequisite condition for an existence of an inverse of a matrix. Okay, so determinant not equal to 0, so then inverse exists. This implies the inverse exists. Okay, so yeah, so ఇప్పుడు మీరు ఈ ఒక ఫంక్షన్ కి ఒకవేళ డిటర్మినెంట్ ఈక్వల్ టు 0 అంటే దెన్ ద మ్యాట్రిక్స్ హ్యాస్ నో ఇన్వర్స్. సో మేక్ det ఈక్వల్స్ టు 0. ఫైండ్ అవుట్ చేయండి ద వాల్యూస్ ఆఫ్ ఎక్స్ ఫర్ ఐ మీన్ జస్ట్ ఫైండ్ అవుట్ ద డిటర్మినెంట్ 1 into x minus 1. Okay, minus 1 again minus 1 into 1 minus x plus x into 1 minus x. So this will become x minus 2. Okay, x minus 2 minus 1 plus x minus x square. So this will become x minus 3 plus 2x minus x square. Okay, so this again turns out to be 2x plus x 3x. So x square plus 3x, sorry, is it x square? Yeah, I think it's, hopefully it's x square. Once again, let's just do the calculation again. 1 into x minus 1 minus 1 into 1 minus x. Okay, x into 1 minus x square. Okay, sorry, this is x square. So this will become x cube. So x minus x cube. So this will become x cube. Okay, so we have finally minus x cube. So I can write it as 2x plus x as 3x. So finally I have the equation 3x minus 3 plus x cube. So I have this equation minus x cube, sorry, this will become minus x cube. Okay, 3x minus 3, this is minus x cube equals to 0. So finally I have the equation as x cube minus 3x plus 3 equals to 0. X cube minus 3x plus 3 equals to 0. So ఇప్పుడు మీరు ఏం చేయండి, can you find the roots of this equation. Can you find the roots of this equation? So ikkada oka technique entante, if you try to see here, right, when you try to actually substitute the values, okay, the x squared term is equals to 0. That means the sum of the roots is equals to 0, right? The sum of roots equals to 0. So I hope I have done the calculation perfectly. So x minus 2 plus x 2x minus x square minus x cube. So I have minus 1 plus x. So x minus 1 minus 2. So x minus 2 minus 3, and x plus x is 2x. 2x plus x is 3x. So 3x minus 3 minus x cube. 3x minus 3 minus x cube. So I have x cube minus 3x plus 3. Okay, so ikkada nunchi now your task is to find the roots. Find the roots of this equation, and then the moment you find the roots of the equation, try to add all the roots, and then you can find the the sum of the roots. Okay. Next, a square matrix of order 3, what is det of adjoint A square? Okay, det of adjoint A square. Now, if you see, what is det of adjoint A? Det of adjoint A is nothing but det A to the power n minus 1, that is 3 minus 1, that is 2. Okay, det of adjoint A is nothing but det A square. Now, det of adjoint A square, okay, adjoint A square is equals to, so ikkada A place lo adjoint A undi, meer em rayochu ikkada adjoint A square whole square, right? Adjoint of A square whole square. Now, adjoint of A is nothing but again det of A whole to the power n minus 1. So that will become det A square whole to the power n minus 1. So 3 minus 1, 2. Again you have power 2. Okay. So this will become det A to the power 4 and again to the power 8. So this will become det A to the power 8. Okay, so malli nenu cheptunanu, if you have any questions please do let me know. Sir, class timing cheppandi. Okay, so every day we have class at 11:30 as well as we have class at 3:30 for the chemistry, and 5:30 we have class again coming back to the maths. Okay, so 11:30, 3:30 and 5:30, these are the 3 class timings we have. Okay, 11:30 and 5:30 maths, 3:30 we have chemistry. Sorry. So again see, so just take this one, det of adjoint of A is nothing but det A to the power n minus 1. Okay, so det of adjoint A, here n is 3, so I can write it as det A square. A వీడు ఏం అడుగుతున్నాడు, adjoint of adjoint A square. A ప్లేస్ లో ఏముంది, adjoint of A square. సో జస్ట్ A ఎక్కడైతే ఉందో అక్కడ adjoint of A square whole square. మళ్ళీ యూ కెన్ జస్ట్ ట్రై టు ఫైండ్ ద adjoint of A square. A ప్లేస్లో మళ్ళీ ఏముంది, A స్క్వేర్ ఉంది. A స్క్వేర్ హోల్ టు ద పవర్ n minus 1, అగైన్ 3 minus 1 2, అక్కడి నుంచి 2 వచ్చింది, మళ్ళీ పూర్తిగా A స్క్వేర్. సో 2 into 2 4, 4 into 2 8. So we have finally the answer to be 8. Okay, that is how we got the answer. Right. See the next one. What is he asking? A square into adjoint of A is how much? Okay. So if you have to first see here, మీరు ఏం క్యాలిక్యులేట్ చేయాలంటే ఫస్ట్ adjoint of A. So this is a direct problem for you. You know how to calculate the adjoint of A. Adjoint of A is nothing but cofactor of A whole transpose. Okay, I'm leaving this problem to you. Okay, cofactor of A whole transpose, and A square, you already know how to calculate the value of A square. You just multiply A into A and you will be getting the answer. Okay, then you let me know how to, what is the answer among these. Okay, yeah. So the next one is, if A is a matrix, then the rank of A is. Okay, ఇప్పుడు ఇక్కడ చూడండి, ర్యాంక్ అంటే ఏంటి, it should be in the increasing order of zeros. It should be in the increasing order of zeros. If A is this matrix, the rank of A is, so ఇక్కడ మీరు చూస్తే ఇక్కడ ఎన్ని జీరోస్ ఉన్నాయి, 1. ఇక్కడ ఎన్ని జీరోస్ ఉన్నాయి, 1. It should be strictly increasing number of zeros. ఇక్కడ 1 ఉన్నాయంటే ఇక్కడ కూడా డెఫినెట్గా it should be 2 or more than 1. It could be 3, 4, whatever it is, but the number of zeros at this point is only 1. But here in the second row it should be more than 1. కానీ ఇక్కడ కూడా number of zeros ఎంత, 1. ఇక్కడ కూడా 1. ఇక్కడ ఎన్ని ఉన్నాయి, 4, that is 3. That's okay, that's still sufficient condition. ఇప్పుడు మీరు ఏం చేయండి అంటే ఈ సెకండ్ రోని కూడా ఈ ఎలిమెంట్ ని కూడా 0 చేయండి. ఎలా, by using the suitable row operation. R2 gives R2 minus 2R1. ఫాస్ట్గా చేయండి ఇప్పుడు. 2 minus 2, so this will become 0, 1, 2, 3, 4. So this will become 2 minus 2, that will become 0. 4 minus 4, this will also become 0. 8 minus 6, this will be 2. 12 minus 8, okay, that will be equals to 4. Okay, so we have this, and we have again 0 0 0, and again we have 4, again we have 8. Okay, now you see here, if you see in the second row we have number of zeros to be 3, in the third row also the number of zeros to be 3, but we want more number of zeros. Like ikkada okati unte next dantlo danikante ekku undali, aa next dantlo kuda the whatever the the consequent is there, it should be more than that. Okay, now here the number of zeros are 3, here also the number of zeros are 3. Now we need to make this fellow to be equal to 0. Okay, so what will be the suitable row operation? R3 gives R3 minus 4 2. So I'll do R3 gives R3 minus 2 R2. సో అప్పుడు ఏమైపోతుంది, ఈ కంప్లీట్ రో కూడా 0 అయిపోతుంది, ఎందుకంటే ఇది 8, 4 minus 4 0, 8 minus 8 0. సో ద ర్యాంక్ విల్ బి ఈక్వల్స్ టు 2. ఎందుకంటే ఇక్కడ కూడా మీరు అప్లై చేస్తే అదే ఆపరేషన్ ఇది, ఎందుకంటే ఈ రెండు దే ఆర్ డబుల్ టు ఈచ్ అదర్, రైట్? సో దట్ ఈస్ హౌ ఐ గాట్ దిస్ టు బి 0. ఓకే, యా సార్ ఫిజిక్స్ క్లాస్ చెప్పరా? Physics class, we are trying to accommodate the physics class in near future, just we need some time for that. And right now I would be confined to teaching you mathematics, and Nidhi ma'am will be taking chemistry. Okay, so that is all the plan is. Okay, right, see the next matrix, the rank of a matrix. So there is a matrix like this. What is the rank of the matrix? ఇప్పుడు మీరు ఇందాక అడుగుతున్నట్టు ర్యాంక్ అని అడిగారు కదా, ఎలా చేయాలో I'll be showing this technique. We'll be constantly using this technique only once and every time, but so just see here. ఒకవేళ ఒక్కొక్కసారి if you can find out the determinant, then there is a chance that you can find out if determinant is not equal to 0, then the rank will be equal to 3. So just ఒకసారి తొందరగా determinant calculate చేయండి, ఒకవేళ ఏమైనా వస్తుందా లేదా. 0 into 4 0, minus 1 4 minus 4 plus 2 into 1, so this will become minus 2 minus this will become totally equals to 0, and this will become plus 2. So determinant is equals to 0, that means the rank will never be equal to 3. The rank will never be equal to 3. So either it might, and it is definitely not equal to 0. So it will be either 1 or 2. So what do? Take the suitable row operation. R2 gives R2 minus half R1. Okay, R3 gives R3 minus 2R1. Okay, R3 minus 2R1. In that case, this completely turns out to be 2 1 2. So 1 minus half, this will become 0, 0 minus half, so that will become minus half, and 1 minus again half, this will become equal to 0, and this will become 0, and again 1 minus 2, that will be equals to minus 1, 4 minus 4, this will be also equals to 0, right? Now again I can make even this fellow also equal to 0, right? Then we can just take some suitable operation. R3 gives 2 times of R1. R3 gives R3 plus R3, in fact minus, okay, minus 2R2. Okay, ikkada nunchi I can just make it to equal to 0. So this will also become 0, and hence how many number of non-zero rows we have? We have 2 number of non-zero rows, hence the rank is equals to 2. Okay, కొంచెం స్లోగా ఎక్స్ప్లెయిన్ చేశాను so that you understand అసలు టెక్నిక్ ఏంటి అనేది. Okay, or else like we can do much more faster and quicker, so just in order to make you understand. Okay, yeah. Now you see the next one. If this is a matrix A where he is asking what is the adjoint of A. చూడండి, whenever ఒక క్వశ్చన్ ఎప్పుడైనా ఇచ్చినప్పుడు స్పెసిఫిక్గా the examiner or whosoever is conducting the exam, they just don't want to know how you are sound enough with the procedure of the problem, but how you are receptive and quicker and faster to get the solution, right? Ikkada you should be smart enough, not like wise enough, right? So ikkada chudandi, there's a problem. You want to find the adjoint of A. Adjoint of A is nothing but cofactor of a whole transpose. Okay, ఇప్పుడు మీరు చూడండి కొన్ని key elements చూడండి, ఇక్కడ -24, ఇక్కడ -24, ఇక్కడ +24. So in order to discard this option, first మీరు ఏం చేయండి, ఈ మ్యాట్రిక్స్ ఈ ఎలిమెంట్ ఒక మైనర్ తీసుకోండి. -6 into 4 -24. ఓకే, -24 వస్తుంది. సో దీనికి you apply minus plus minus plus minus minus, అది ఉంటుందిగా, ప్లస్ మైనస్ ప్లస్. So plus into minus, again it is -24. Even after you do the transpose, the element will be same. So this option is definitely wrong. Okay, so among these 3 options, ippudu ee mooditlo try to find some fellow where we can discard one option. ఓకే సో ఇక్కడ -10 ఓకే ఇక్కడ -10 ఇక్కడ కూడా +10 ఇక్కడ కూడా -10 సో ఈ మూడు ఆప్షన్స్లో వేర్ సో ఇఫ్ యూ ట్రై టు టేక్ ద ట్రాన్స్పోజ్ of which element so that again this will be equal to 10 ante try to find the cofactor of this, because if we take the transpose, this element will be shifted over here. So what it will be 1 into 1 into 0 0 minus of minus plus 10. Okay, so here the element will be plus 10, right? Here the element will be plus 10, but again plus minus plus, okay, plus minus plus, and again you will be taking minus plus minus, so that is what you will be taking, and then you will be multiplying 1 into 0 0 and minus of minus plus 10, so plus of minus it will become minus 10. So here it will become minus 10, and if you take the transpose it will again be shifted here. So final ga, so this option is wrong endukante ikkada plus 10 undi kabatti. So we are not doing entire calculation. I hope you are getting. Adjoint of A ante entante cofactor of A whole transpose. ఓకే సో ట్రాన్స్పోజ్ చేయకముందు ఎలిమెంట్ ఎక్కడుంది ఆ ఎలిమెంట్ ఒక మైనర్ ఫైండ్ అవుట్ చేయండి, దెన్ యూ డూ అప్లై ద సైన్ టు దట్ మైనర్, దెన్ యూ విల్ గెట్ ద కోఫాక్టర్ అండ్ దెన్ టేక్ ద ట్రాన్స్పోజ్. సో జస్ట్ వీఆర్ గోయింగ్ ఇన్ ద ఆపోజిట్ సెన్స్. సో ఇట్స్ జస్ట్ లైక్ బేసిక్ టెస్ట్. సో ఇది కూడా ఆప్షన్ రాంగ్. సో ఇప్పుడు ఈ రెండు ఆప్షన్స్లో వాట్ ఈస్ ద వన్ డిసైడింగ్ వాల్యూ వీ హ్యావ్? హియర్ వీ హ్యావ్ -2. ఓకే ఇక్కడ మటుకు -2 ఉంది. ఇక్కడ చూడండి ఈ ఎలిమెంట్ని ట్రాన్స్పోజ్ చేసినా కానీ సేమే ఉంటుంది, ప్లస్ ఇట్ ఇస్ ప్లస్ మైనస్ ప్లస్ నో డిఫరెన్స్. జస్ట్ ట్రై టు ఫైండ్ డైరెక్ట్లీ a minor of this. 1 into -6 -12, minus of minus it will become +4. The answer is -8. Okay, 1 into -6 sorry 1 into -6 -6, and this is +4. The answer is -2. Okay, so answer is -2. The option is C. The option is not A. So here we didn't calculate entire cofactor matrix, entire adjoint of A. Okay, we are just trying to find those values. These are the culprit values we have found and we got the answer. Okay, simple, easy and very easy. Okay, next ఇప్పుడు we have just dived into the part of system of equations. We have three system of equations. He is asking whether the solution is infinite, no solution, unique solution. I'll just try to again tabulate the whole tabular column over here. If rank of A is equals to rank of AB is equal to n, then it has unique solution. ఎప్పుడు అన్ని ఈక్వల్ ఉంటే యూనిక్ సొల్యూషన్. ఒకవేళ కానీ rank of A is equals to rank of AB, if it is not equal to n, then it has infinitely many solution. If rank of A is not equal to rank of AB, then it has no solution. Right, here is the complete tabular column, as well as I would like to always give you the determinant for each and every case. ఎప్పుడైనా కానీ ఎక్కడైనా కానీ కంప్లీట్గా ఈక్వాలిటీ ఉంటే అక్కడ డిటర్మినెంట్ ఈక్వల్ టు 0 పెట్టేయండి. దట్ మీన్స్ డిటర్మినెంట్ ఆఫ్ A is equals to 0. సారీ, హియర్ ఇట్ ఈస్ ఈక్వాలిటీ, దెన్ టేక్ డిటర్మినెంట్ నాట్ ఈక్వల్ టు 0. ఎక్కడైనా కానీ ఒక్క చోట అయినా కానీ హియర్ ఇన్ఫ్యాక్ట్ నాట్ ఈక్వల్ టు కంటే కూడా ఇట్ విల్ బీ వెరీ బ్యూటిఫుల్ వెన్ యూ ఆర్ పుట్టింగ్ లైక్ లెస్ దాన్, రైట్? And if determinant equal to 0, then you can say then yeah. So determinant equal to 0 does not assure you whether the condition is infinitely many solution or no solution, but definitely determinant not equal to 0, it's a clear cut shot ki yes it is equal to unique solution, right? So ikkada meer em cheyandante, the first thing is you just try to take the quickly you try to write this augmented matrix 1 2 1 minus 3 3 3 minus 2 and it is equals to -1 2 7 7 minus 4. Okay, I have these values. Ippudu you try to just take the row operation. R3 gives R3 minus R1, R2 gives R2 gives R2 minus 3 R1, R3 gives R3 minus 2 R1, right? R3 minus 2 R1, yeah. So from here you will be getting the according to the row operations that you have. Nenu ikkada em chestunna, R3 gives R3 minus 2 R1, R3 minus 2 R1, R2 gives R2 minus 3 R1. So in that case you just write 1 2 1 minus 3, and this will become 0 0, and 3 minus 6, which will be equals to -3, and again this will become 7 minus 4, that will be equals to +3, minus 2, and here you will multiplying with 3, -2 minus 3, that will be -5, and the next one is minus 1 plus 3. So minus 1 plus 9. Okay, so minus 1 plus 9 will become, so that will become 8. Okay, the similar one 7 minus, so this will become 7 minus 2, this will become 5, and this will become minus 4 plus, you are taking minus 4 plus 6, that will be 2. Okay, minus 4 plus 6, that will be equal to 2. Okay, yeah, so now we can directly take R3 gives R3 minus R2. Okay, our case like complete ga e value kuda 0 aipotundi, e value kuda 0 aipotundi, and then you have this fellow to be sustaining over here, right? This will be not equal to 0, right? So this is not equal to 0, not equal to 0, right? Now if you try to see only just ikkada meer chuste, if you try to see here, if I just try to cover this and if I try to find the rank, endukante idi kuda 0 vachesindi, idi kuda 0 vachesindi. So what is the rank of this matrix completely? This will be equal to only two non-zero rows. And when I try to just pull it off this, and if I try to take the rank of the whole matrix, now if you see here you see the first row is non-zero, second row is non-zero, the third row is again non-zero. So I got rank of A is not equal to rank of AB, because the rank of A I got to be 2, the rank of AB I got it to be 3. So hence I can say that it has no solution. See here, rank of A is not equal to rank of AB. ఇది ఇంత క్లియర్గా ఎలాబరేట్ చేసా, కానీ మీరు ఎగ్జామ్లో డోంట్ టేక్ దిస్ మచ్ అమౌంట్ ఆఫ్ టైమ్, యూ షుడ్ బి క్విక్ ఎనఫ్ ఓన్లీ టు మేక్ యూ అండర్స్టాండ్ నేను ఇది చెప్తున్నాను. సో విల్ టేక్ వన్ ప్రాబ్లమ్, కొన్ని ప్రాబ్లమ్స్ ఐ హ్యావ్ లెఫ్ట్ అవుట్ ఫర్ యూ. ఇఫ్ పాసిబుల్ ఐ ట్రై టు అకామిడేట్, రేపు స్టార్టింగ్ ఆఫ్ ద లెక్చర్లో క్విక్గా ఫాస్ట్గా తొందరగా కంప్లీట్ చేయడానికి ట్రై చేస్తాను మిగిలిన ప్రాబ్లమ్స్, బికాస్ ఐ నో దట్ దేర్ ఆర్ సో మెనీ పీపుల్ లాగింగ్ ఇన్ దిస్ పర్టికులర్ కాన్సెప్ట్, బట్ ఐ వుడ్ లైక్ టు కంటిన్యూ the legacy of the problems that we have started, right? Okay, if the set of equations we have is x plus 2y plus 3z equals to 6, x plus 3y plus 5z equals to 9, 2x plus 5y plus az equals to b, has a unique solution. Okay, he's saying it is having a unique solution. Then ardham enti, rank of a is equals to rank of ab and it is equals to n, and also determinant value is not equal to 0. Determinant value is not equal to 0, right? So whenever you are taking this sort of values, so fast ga meer em cheyandi, take the matrix 1 2 3 6 1 3 5 9 2 5 ab 2 5 ab. ఇప్పుడు మీరు ఫైండ్ అవుట్ చేయండి దీనికి. హౌ కెన్ యూ ఫైండ్ ద ర్యాంక్? టేక్ r2 gives r2 minus r1, r3 gives r3 minus 2 r1, right? So according to that operation, that will become 1 2 3 6, this will become 0, this will become again 0, 3 minus, so 3 minus 2 which is 1, 5 minus 3 which is 2, 9 minus 6 which is 3, again 5 minus 4 which is 1, a minus, this will become a minus 6, okay, a minus 6, and this will become b minus 12, okay, b minus 12. Now again try to take r3 gives r3 minus r, so this will become 1 minus 1, this will become equal to 0, okay. So just take the r3 gives r3 minus r1, so this will become 0, this will become 0, a minus 6 minus 2, this will become a minus 8, and now b minus 12 minus b minus 15. So only when I have a value not equal to 8, ఒకవేళ కానీ ఇక్కడ a value 8 అయిపోయింది అనుకోండి, ఈ పూర్తి వాల్యూ కూడా ఎంత అయిపోతుంది? 0. ఇక్కడ కూడా 0 వచ్చేసింది అనుకోండి, అప్పుడు ర్యాంక్ ఆఫ్ మ్యాట్రిక్స్ ఏమైతుంది? 2, ఎందుకంటే 2 నాన్ జీరో ఎలిమెంట్స్, ఎందుకంటే ఇక్కడ కూడా ఇది 0 వచ్చేసింది కాబట్టి. దేర్ ఇస్ నో పాయింట్ అగైన్ వెదర్ I mean like whether the discussion goes on to the augmented matrix or not, ఎందుకంటే augmented matrix దగ్గర ఒకవేళ ఇక్కడ ఎలిమెంట్ ఉన్నా లేకపోయినా కానీ the case goes to infinitely many solution or no solution. So definitely a should not be equal to 8. I hope మీకు అర్థమైనట్టుంది. ఇక్కడ ఒకవేళ a 8 వచ్చింది అనుకోండి, ఈ వాల్యూ కంప్లీట్గా 0 అయిపోతుంది, దెన్ it is definitely not a possible condition, right? So you can even verify this value taking the determinant not equal to 0, right? So akkadi nunchi kuda, and once you got a value here not equal to 8, that means there is a non-zero value that is existing over the third row, and b can be any garbage value, let it be 15 or let it be anything, and at that point, so it doesn't matter, so b belongs to r, so the option is option b. మీకు అర్థమై ఉంటుంది. ఒకవేళ ఇక్కడ నేను a ఒకవేళ ఆపరేషన్ అప్లై చేసిన తర్వాత I got a equals to 8, ఇక్కడ b is equals to 15. ఇప్పుడు నేను ఒకవేళ a 8 సబ్స్టిట్యూట్ చేశాను అనుకోండి, ఈ పూర్తి రో ఇఫ్ ఐ ట్రై టు సీ హియర్, ద మ్యాట్రిక్స్ a will be, the rank will be equal to 2, but which I don't want, because I want rank of A should be equal to 3, right? And rank of AB should also be equal to the same, right? So once I can restrict this A to be 8, the B can be any garbage value. So that is how I got. So further ga manam tarvata problems chuddam. Okay, in tomorrow's class I'll try to explain you if possible. So we have few more problems. I have 10 more problems. I would like to cover this concept as quick as possible. Okay, yeah, so tomorrow's class we'll just try to see these problems. Okay, so thank you so much. Okay, Prati Roju, again we have classes at 11:30 as well as at 3:30 the chemistry classes will be there where Nidhi ma'am will be taking. Malli 5:30 again I'll be coming back to take the classes. Please do follow us on YouTube, as well as there is a barcode scanner. Please scan and you can download the Sysya app, and please do share this app among the people, among your friends, as well as in your locality. If you have any siblings, and if you have anyone, your cousins or someone who is in 10th grade or in 1st grade or 2nd grade, 1 to 10th grade of any curriculum, right? The exclusive content is there where all the IIT and NIT teachers are there, who are working, who are just behind all the content, and they would be the one who would be confronting your classes. So వాళ్ళు ప్రత్యేకంగా వచ్చి 1-to-1 classes మీకు available ఉంటారు. So please do share among you, among every of your friends and colleagues also. And yeah, so thank you so much. Okay, please share, like and subscribe to our YouTube channel. Thank you so much. Stay tuned. Again tomorrow we'll be meeting sharp at 11:30.